add to your series list. So let's pause. So when you do series problems, you have a lot of learning to do. But this is the flowchart of thought that you're going to gradually add to. It goes something like this. You're given an infinite series, and you want to know if it converges. That's the question. The very first thing you check is, do the terms go to zero? The divergence theorem is the first thing you look at. Now think in terms of results of that. If the answer is yes, then what does that imply? It might converge, and you need to investigate further. If the answer to that is no, then what does that imply? It diverges and you're done. If the terms don't go to zero, that's the best case, because boom, you're done. That's the first thing you should always check. Always. That's the very first thing you look at. Does it even have a chance? Does it even have a chance? You with me? Now, say it has a chance, then you might then say, is it some kind of known series? One of which might be yes, it's geometric. In that case, you would say, what is R? Is R less than 1? And you do your thing from there, yeah? It might not be geometric, but it might be telescoping. In which case, you're decomposing and see if it has partial sums that approach a limit. Yes, telescoping. However, sometimes the answer is no. I don't know what that is. Let me give you an example. Here, this. Is that geometric? No. Is it telescope? No. So at that point you'd say, I guess I'm done. I don't know. It might converge. Call it a day. Well, there are a ton of other things then you could do after that. There's all these other tests for convergence. Now, there are many you will learn. You will learn the integral test, the direct comparisons test, the p-series test, the alternating series test. You're going to learn a boatload of other tests depending on the situation. They might serve in one case better than the others. Now, that's stuff to come, including today. All right? Now then, going to the, oops, my notes are out of order. Sorry. Going to today's notes. Oops. All right, p-series. P-series are the second most famous series. Never mind. All right, a p-series. First of all, we've talked about improper integrals. Now, that was no accident that they just had you learn improper integrals recently, because it lays the groundwork for p-series. Remember, some of these converge and some diverge, like this. So you're talking about usually the tail of a function, if you think area-wise, that could reach a finite area but might not, depending on how quick it gets small. So for example, if you made this x squared, then the terms would get small fast and the area is finite. But if you made it x, the terms don't get small fast enough and it's not finite, it's infinite. Do you remember the dividing line? Like x squared converged, but x diverged. That's true, greater than 1. Now, remember back why. When you integrate this, what's the integrand? 2 over x, yeah? Or negative 1 over x, isn't it? Yeah. Okay, negative 1 over x. And if x gets big, doesn't that converge? Because x is still in the denominator. 1 over infinite, it's 0, yeah? Are you with me? Yes. Okay. This, however, when you integrate it, was the integrand, or antiderivative. Log. And log of infinite is infinite. So there's this great dividing line between what the powers are and whether it will converge or not. And the great dividing line is 1. If the power is greater than, what about equal to 1? When it's greater than 1, it converge because the terms get small fast and adding them all is doable. But if p is less than or equal to 1, then it diverges. Now that is the same idea for a p series. Integrals are infinite. I should just go to the next part of my notes. Integrals and series are very similar. Integrals and series are similar because they are both infinite sums. Now they're slightly different because when I talk about this problem, 1 over x from 1 to infinity, x is what kind of numbers? Can you have decimals? Yeah. Okay. But when I talk of this series, what kind of numbers is it? It's whole numbers. Okay. You don't do the 0.2th term. You know what I mean? So they are slightly different in the domain. The domain. X is all reals, but n is whole numbers only. Now because of that, they're not exactly the same, but there are a lot of similarities. Most importantly, they're similar in their convergence. An integral and a series converge in the exact same fashion. Now, so just like the integral, the improper integral 1 over x to a power converges when p is greater than 1 and diverges when p is less than 1, that is exactly the rule you use for this series, which is called a p series, a power series. You don't call it power series because that's now some other name. But p standing for the power of n. That's a, does yours? That's making it clean. Does yours? It does? Oh, God. You're about to put die and divergence. I had a Freudian slip there. Divergence, not die. Just divergence. Convergence and divergence. In the same way as the integral. Now, that is to say, if you get a series like this, 1 over n to some power. Now, p, in a problem, p will be named. It'll be n squared, or the square root of n, or n to the third. So, generally speaking, p will be given. N stays in, n varies. But it'll converge if p is greater than 1 and diverge if p is less than or equal to 1. The V series, 1 over n, is the most famous series of all. 1 over n is called the harmonic series. I don't know why it's harmonic. I honestly don't know why the name, because it does not oscillate. But it is what it is, all right? So just so we're clear, I don't know what the next part of my notes is, but I just want to distinguish between. So what kind of series is that? That's geometric. What kind of series is that? That's a P series, okay? N to a power. N is the base. Okay, this is geometric. That's a P series. What about this? That's a P series. Okay. Now, it's important to note that anytime they throw any kind of, actually I'll go here. We've done that before. What kind of thing is that? That can be split into a sum of geometric, yeah? 2 over 3. So that would be sum of geometric. What if the sum was in the denominator? 3 over n. Actually, I'll make it so it's. That's not, if you look at a term or two, say it starts at 1. What's the first term? 2 over 1 plus 3, or 2 over 4. What's the second term? 4 over 1 plus 9 or 10. So if you were to look at this, 2 fours, 4 tenths. What's the, I need the one more term. What's the next term?
8 over 20.
All right. Is this geometric? Is there a common ratio each time?
No.
This is not geometric. So it varies a lot. When you start throwing in added constants, it messes the whole system up. The same is true for something like this. If I said 1 over n squared, is that a p-series?
Yeah.
Yes.
It is, but if I put 1 there,
Nope.
No.
it's not a p-series anymore. All right, it's a comparable series. We'll talk about that tomorrow, but that's not a p-series, understood? So it's nothing but 1 over n to a power. That's it. Good? All right. Yep.
What if it has a number inside of the square?
That is okay. That could be separated out. That's a good question. All right. So in terms of justifying, these are super duper easy on the homework. They'll take no time whatsoever. So a pretty common problem is, does the series there converge or diverge? So whether you write it on your paper or not, please, I beg you, get in the habit of the first thing. The first thing you do is say, do the terms go to 0? Does it even have a chance? Do the terms go to 0?
Yes.
Yes, okay, it has a chance. And then we say, all right, classify it. Is it geometric, P, telescoping? It is. Is it geometric or p-series? It's a p-series. That is what you will say first. You'll say this is a p-series. Then you will say P is this, which is what? 3. And then you show the test condition. The condition is it is greater than 1, so we conclude convergence. And that's all you gotta do. You gotta say what kind of series it is. You gotta say what the P is and how it tests against the value of 1, and then you conclude converge or diverge. That's all you gotta do. Pretty easy. With me? Try one. Ready? What's the first thing you said? P-series. Then what did you say? P is 3/4, which is less than 1, or less than or equal to 1, whatever you like. So we conclude divergence. In other words, you're adding lots of terms, but they're not getting small fast enough, so the sum just kind of spirals out of control. All right. Now, the rest of these are AP-style practice problems. So work the rest of these with your math amigos, and we'll go over the answers.
I was thinking absolutely. Why does that so
Because you have to make it a fraction, and every other one,
Oh, it's 1 over. Yeah.
yeah. So you've got to make it as small as possible,
And
right?
it can't be negative. That makes sense.
Yeah. There's a whole ton of negative. Negative x squared.
I was very drunk.
I always feel diabetes instead of tree.
No.
Die.
Because if you put it down,
Wait, is that an external telescope? It doesn't give enough terms. No, mine is it's still metric. It multiplies by to make it over third one? Over 3, right? Number 2! So be geometric.
like when you're saying
Wait, this is getting closer to 0. So it's gotta convert. So 1 and 3? Boom!
Number 2 on the back is calculator active, as you might have gathered from the decimal answers.
You're not enough. Because otherwise it will be n over n to 1 half.
Oh wait, so that would equal
Hi.
So if k is greater than 0, we get n over n to the 1 half. Yeah, which means the top one's like the bottom one be equal or more than it. It doesn't help at all. So what I was thinking about was you've got to make these equal or you've got to make this one greater. And the way that that works is just by making k equal to or greater than 1. Because they'll be equal when when the bottom is power 2. Square root.
Which one are we on? 2? Okay.
no, so like, it's just to what number does the sequence on? So it takes 3
How are you guys working on 2? I don't even know what it is. Multiplies by like an R, right? What would the R be with?
multiplied out 7 plus n to 20.
Tangent of it's got to be a number.
you can put the coefficient device yeah. 1 over
Which exactly cancel out?
1 over cosine of x a x 1 over cosine of x. Oh, sorry, cotangent to the x is what I thought you were saying. No. Because then it's at the bottom, so it's
But also cotangent is different than tangent. So you can't do that.
1 over tangent. Okay, it's tangent.
Oh, 1 over cotangent, that wouldn't be tangent. Sorry. We're working on like 3 hours before.
It's okay, I want to
Number 5.
Oh, I did it too.
Oh, which 5?
Would it be like 1 over cotangent of x and all of that? Yeah.
There's a lot of learning to be done here, but these are humdingers whether you know it or not. And if you think they're easy, then you're probably doing them wrong. Some of them.
Yeah, there is, but it's
So 5
Yeah, I'll probably do it. Yes, correct.
And there's everything from 1 to infinity.
Oh wait, I see what's going on.
I might go to D.
What's for changing the
I go to D. Increase our chances.
Oh yeah, we all get some different answers. One of us. Oh, okay, that's good.
Okay, so
Calculator.
Anderson.
I was thinking about cotangent.
That's good.
number 5
Oh, good. It's more of a.
You're right.
This now is one.
K is greater than.
So let's say you plug in like.
Oh, wait.
Well, you say, no, yeah, no, 7's always fast, because I said there's 20 extra.
Oh, and then, like, but the ends cancel. So then it's
No,
7
the end's inside K.
But that's wrong. Is that your
Almost done.
You were right. It is.
Struggle with your extra point. No,
I said,
can't find an error in your logic.
K plus
Oh.
Oh. That's a K though, not an N.
Yeah. How about another minute? What do you say? Wait, wait, wait.
And then 3 to the end.
You're not ready?
Alright.
And then you these guys
Always do. No. You can tell you.
I think someone told me.
But I did 7 points. We're both right. How many are they gonna be?
Oh, I think those actually two. There's definitely a 3 in the denominator. So it has to be 3.
So it's 1 over 3. So it's 7 plus n. No, never mind. I want to clean this up. It's 7 over
Okay, over 2.
7 20s. 3's. So what's
No, wait a minute. Okay, I can't do math.
are you like say it's all just clean all together. I also have that
My negative
you do
1.
know. You know the rules for Xbox?
We're changing
I think so you can split it to 3 to the n times 3 to the 3. Wait, it's B, isn't it? It's totally C.
Alright. For the most part, it looks good. So, take 1 more minute to finish and we'll go over it.
No, I did. Moved over to this side.
Oh, but then.
Well, I had it in my
Okay, wait. I need this back.
Now what? Why?
What are you talking about? Okay, let's get back together, shall we? Let's see. Let's go to you, Bench. Not anymore. Yeah, good you, Bench. Yeah, okay. So what could you bench?
I don't remember.
All right, so could you bench 300?
Oh, probably not.
Okay. Now, that said, if I said, all right, if I said get on that bench and I put 300 pounds on there, would you get a workout in trying to keep it from crushing you?
Maybe for a little bit.
You would get a workout. If you just stood off to the side and said, screw that, I ain't doing that, would you get any workout by saying, screw that, I'm not trying? Okay, so when I give you something like this, I expect it to bury you, like 300 pounds, all right? But you get a workout by getting buried. If you just say, I don't know, I don't get it, you get nothing. You get nothing out of that, all right? So just struggle. It's intended to be a struggle. Here we go. This guy, I don't know about you, but I played with this a little, and I said it's something like, do you agree this is what's changing each time? So it's n to the x, but to make it like a p-series, what did you do?
Made it negative.
Made it negative, so 1 over n to the negative x. The first thing you do is make it look like a p-series, and then use the criteria. What makes it converge? If
If
x or negative x. If the exponent you see now, which is negative x, is greater than 1. That implies x is less than negative. Less than negative. The answer is B. Did you get it?
Yes.
Okay, so make it like a p-series. Cool. The next one, what do you say for 1? Zach, you were taking random guesses. Did you guess correctly on 1? What did you get for 1? What kind of series is it? In number 14, series 1, sorry.
Well, we knew one was easy.
Okay, cool. And what's the p?
Two.
All right, does that make it converge or not?
Yes.
All right, so that converges. Can we all agree that 1 converges, yes?
Yes.
Cool. 2, what kind of series is it? Somebody from this p-series. It is a p-series. This is we got a little Siri thing. This whole semester will be the same thing. So what is the name of that p-series? Harmonic series. Does the harmonic converge or diverge? Diverges. And what kind of series is the last one? It's geometric. What's R? Negative 1/3. So does that converge?
Yes.
Okay, so what did you conclude? C. Correct. All right. The next guy. This is very common. If you keep it structured, you'll have a much easier time. But when I say keep it structured, you want to make it look like a nice, clean p-series. You want to combine it all so it's nice and clean. So if I do that, what does this end do when I move it down?
Negative 1.
Negative 1. And what about the power of the other end?
K plus 1 over 2.
K plus 1 over 2. Now if I combine those further, what's the total combination power? N to the... What do I do when I multiply with exponents? Add them. So I'm looking to add K plus 1 over 2 minus 1. Now it looks like a p-series. Are you with me? All right, so now we state the condition. K plus 1 over 2 minus 1 needs to be greater than 1. That's a plus, yeah? I think it's a plus. Okay, so now how do you solve for K? Add 1. K plus 1 over 2 is greater than 2. Then K plus 1 is greater than 4. So K is greater than 3. K is greater than 3 is your answer. Okay? This guy, this one tends to kook students out because you see 2 variables. But is x really a variable? No. What do they say to put in for x? 1. So the series becomes tangent of 1 to the n. What kind of series is that? Tangent of 1, is it a variable or a constant? Constant. What do you call a constant to a power? It's geometric. That's a geometric series. Now the question is, what's the current ratio? Well, I don't know what tangent of 1 is. It's not arctangent of 1. Okay, arctangent of 1 we know. But tangent of 1 radian, I don't know. So what's the tangent of 1? Somebody? 1.5, whatever, that's all I need. Is that then a ratio less than 1?
No.
No, it's not less than 1, so I conclude a divergence. Okay? All right, this one is rough. The big message of the day is 2 words: clean up, clean up, clean up, clean up. Gotta clean it up. These guys, they are kind of similar. Yeah, they have that n thing going on and a 20 going on. So put them together. Call it a big fat 7 plus n over 4 plus n to the 20. Yeah? And the other guys, put them together. 3 to the n minus 1 over 3 to the n. Now I should pause and say I should step back here. What's the question? Is this a series question or a sequence termsy kind of question?
No, it's the sequence.
Sequence. So I'm not looking to add anything. I just want to know, do the terms approach, do the terms have to go to 0 here, or do the terms have to just go somewhere to a number? Yeah, I'm not trying to add them, so I don't care if they go to 0 or not. I'm just saying, do the terms approach a limit? So I need to take an infinite limit on this, yeah? All right. Talk to me about, let's actually talk to me about this. Can that be cleaned up more? What is it? 1/3, how'd you do that? There's several ways to think. Yeah, so if you could do it this way, you could say, I'll split these up, and then that's 1/3. You could take upper minus, isn't there an exponent rule, top exponent minus bottom exponent? What's n minus 1 minus n? -1. Okay, so any which way you look at it, this is 1/3. Now we're getting somewhere. End behavior. As n goes to infinity, what does this approach?
7/4.
1. Why? 7 and 4 being different doesn't matter?
2/3 arbitrary.
Yeah, does adding 7 mean jack anything to a trillion? A trillion and 7 and a trillion and 4. Those are pretty much the same. You agree? So what is this approach?
1.
That approach is 1. That approach is 1/3. The limit is
1/3.
follow? Okay. This one kind of stinks. I should have left it out. Let's just talk about planar. What kind of series is that? It's telescoping. Oh, you don't have this one? Oh,
Oh, I was wondering why it's the telescoping.
Yeah, I don't-
I was like, that's not telescoping.
it's a bit of a time eater. Here, is this one still there?
Yes.
Okay, cool. What kind of series is this? Is it okay to look at expanded form, or would you prefer to write this in series summation form? If you do that, what is it?
N.
1 over n, oh no, actually it's not.
Square root of n to the k.
It looks like n to the, actually, doesn't this give you the general form right there?
Yes.
So I guess I was looking at this stuff for no reason. Can't we just look here?
Yes.
Oh, yeah, sorry, my bad. All right, so there, yeah. Is it looking like a p-series should look at? Make it like a p-series. What is this? 1 over n to a power, what? Negative k over 2. Now that it looks like a p-series, now you can do the criteria. It converges if negative k over 2 is
Less than -2. Wait, no, not
Less
that.
than 1.
greater than 1, right? Greater than 1 is the condition. Negative k is greater than 2. And when you divide by the negative, you
Flip it.
flip the sign. So k is,
-2.
that's the -2. Are you with me?
Yes.
Please pause stop me if you don't understand what I'm doing.
Sorry.
Okay. Last but not least, this guy. Wow, I don't see any powers. What is this? The series of 1 over,
N
I agree, n cubed. Does it converge or diverge?
Converge.
Why?
P
P-series, p equal 3 greater than 1. We conclude converges. Remember, that's the good work should look like. What about this? What's the series in normal summation notation? N to the 2/3. P-series?
Yes.
P equal,
2/3.
which is less than 1, so we conclude divergence. Got it? That's it. Okay. All right, these will take practice, but it sounds like you're doing fine. Questions on set 120? 125? 126. Questions on 126, number 25.
15.
15. 23, did I hear?
13 is numbered. What?
13, yeah, sorry, 13 should have been 12. That's why
Okay,
there's
that's
a
what I
first.
thought.
Probably figured it out. Okay,
7.
7. Okay. 25 is 25 still a question?
It's not actually 13, because 13 is like an equation. Oh, it's like, you did 12, you did it right. Okay.
Yeah, 25 is a bit of a
Yucky,
difference.
yucky, yucky.
I just absentmindedly did it right.
See, I guess that's what I was doing. That's actually C and then DID.
Okay, so they say it's odd,
Yeah.
odd, and extremes at x equals plus or minus q. All right. If it's odd in a cube, then what does that mean about the graph odd? What does odd tell you about the graph?
It's symmetric about the origin.
Okay, so first question for you. What does that imply about D, the y-intercept D? Y must it be 0? You cannot be odd with a y-intercept?
Yes.
That's correct. If you have something, if you pass through anything but 0, you're right away not going to be symmetric about the origin. You cannot. Okay? And so D must be 0. I'll actually do you one better. This also must be 0. The even term, even power term, both of these have to be 0. Now proving that one is a little harder, but if you would just take my word for it, the even powered must also be 0. If I try to negative x, the only way for this to be the same or opposite is if b zeroes out. All right? So right away, I know that p of x is strictly just x cubed plus c x. You down? The even terms must be gone for it to be odd. All right, now that said, we're supposed to find c. We found b and d, they're 0. C, how do you find c given that cube fact?
Can you put it right?
Yeah, let's go with p prime is 3x squared plus c. It must equal, that's true, the derivative is even, but it must equal 0 when what? X is going on. When x is q or negative q, yeah? If I have an extrema, it must be the case for a cubic that there's a horizontal tangent there. So that means 3, it wouldn't matter if you put plus or minus in because it's going to be squared anyway. So 3q squared plus c equals 0. That means c must be
Negative 3q squared.
3q squared. And I guess that's all I can do because I don't know what q. You done?
Yes.
Okay. 15. Question on 15.
Yeah.
All right, 15. Determine if this bad boy converges or diverges. I have the first page of your test, by the way, graded, but I can't hand it back yet. We'll go over it tomorrow. It's going pretty doggone well, I gotta say. It's pretty great. 3 to the n over 10 to the n. Okay, so if you went telescoping, decomposing, then you wasted your time because you didn't do the first step. What's the first step?
Separate.
Do the terms go to 0? I don't even need to separate to do that, but I can. This. What are the terms? What's the limit of the terms? Infinite. Not 0. Diverges. Done. you can't, this is getting infinitely large and you're adding infinitely many of them. There's no way. There's no way. Right? 23. First thing you check is, does it have a change? 23. I'm assuming these are all normal out of the book, right? I didn't replace any of these. Okay. 23, particle squared. It's been a while since we did one of these. Huh? Distance from time equal -2. Okay. Talk to me. Is distance this guy or this guy here? The first one or the second one? Second one. So you're telling me there are two dimensions in this problem?
No, there is not.
No, there are not. There's one dimension. It's linear movement, not planar movement. So the first thing you should do in your, I'm going to put together a handout for this. I think we need some clarification.
I would agree.
Okay, so if it's linear movement versus planar movement, well, planar movement will be parametric. It'll be an x and a y equation. And in that case, you go here. But this is just one-dimensional movement. So we're moving along a number. So it's this guy, yeah? So the first thing we're going to need is v. V is prime of t, so 2t minus 3 from -2 to 5. Now, obviously, the absolute value has an effect. I can't just integrate that without and just blow off the absolute value. What do I do? Yeah, I need to see where it's flipping, and I know where, so I know where it's flipping and not flipping. Do you agree? Okay. So where is it zeroing out? 3 halves. It's at 3 halves, and it's V-shaped there, right? So from -2 to 3 halves, it's, I guess, negative V. Let's call it just negative V. Are you with me? And from 3 halves to 5, it's normal V. We? Does that make sense? Okay. What's the antiderivative of negative V? Negative x of t, yeah? From -2 to 3 halves. And what's the antiderivative of V? Position, yes? All right. So now you just need to kind of go off to the side and make these calculations. What is the opposite of x to the 3 halves? Actually, maybe I should hold off on this. This is, I don't know, I don't think so. Opposite of x to the 3 halves plus x to the -2 plus x of 5 minus x at 3 halves. So this is x at -2 plus x at 5 minus 2x at 3 halves, yeah? Is that hard to do mentally? Why would I?
So negative v is, or v is just 2t minus 3, right?
Yes.
The antiderivative of that be t squared minus 3t.
Yes.
But then x of t would be t squared minus 3t minus 4.
That's true, 100% I agree. The thing is, though, because you're subtracting in the fundamental theorem, that 4 would go away anyway. So yeah, if you'd rather, maybe it is a little cleaner calculation-wise to do what you're saying, and maybe you should do that, yeah. That's a good idea. Okay? All right, that should get you started there. You can do arithmetic, I hope. 7. Is 7 still a question? Okay. 7 is the new partial fraction decomposition, irreducible quadratic. Mouthful. Negative x squared plus 2x plus 3. X squared plus 2. Okay. So, first, just to get in the habit, do you need to divide this first? Whose question is this? Okay, do I need to divide this first?
No.
When do you have to divide? When the numerator's as big or bigger than the denominator. So always check that. Our book doesn't do those, but you can't forget that because other books do. The AP test does. So it does not need to be reduced. So you go to decomposing this. What were your fractions?
X squared plus 2.
And what in the top?
AX plus
Perfect.
plus C over X plus 1.
Okay, so we're good there. All right, so let's go to the next thing. Did you multiply correctly? You have ax plus b times x plus 1 and c times x squared plus 2? Okay, so how do we zero out one of them?
Let X equal -1.
Okay, so when you do that, what kind of result did you get?
C is -2.
C is negative what?
2.
Okay. All right, now the harder part then, what about, how do you get the a and the b?
You set the number of X squared.
Okay, so negative x squared equals how many x squareds on the right? A and c. So that implies a plus c is -1. If c is -2, then a minus 2 is -1, which means a is positive. Cool. Then we need b. B involves x's and constants. Which one do you want to do? Constants, okay, so the constants on the left are -3, and the constants on the right are b plus 2c, yes? So -3 equals b minus 4, so b is 1.
Yep.
So that's what you did and it did not come out? Or the integration coming was the problem?
The integration point.
Okay, so here we go. Our new integral then is x plus 1 over x squared plus 2 and
-2 over X.
2 over x plus 1. So obviously the 2 over x plus 1 I'm sure is fine, but let's go in here. Did you break that one up into 2 separate?
No.
Alright, that's the first thing you gotta do. Now even there you're not out of the woods. This is u sub. That you'll probably be fine on. Do you see why it's u sub if the power works out nice for u sub? Yeah. If you let u equal x squared plus 2, you'll be rolling there. The other one, you have two choices. Have a nice day. Trig sub or more like make arctangent. I think it's easier to make arctangent. So I factored out a half. So that it starts to look like 1 over u squared plus 1, which is arctangent. So then I'd let u squared equal x squared over 2, which means u is x over 2, and du is dx over 2. I know I'm going fast, sorry. So it becomes 1/2, oops, that's root 2, isn't it? Sorry. Hi.
One of the problems on problem set is the T-series, it's the answer T-series converge. Then it asks what does it converge to?
Did I write a note saying estimate with your calculator? I didn't?
On the problem set?
Yeah.
No.
There's no formula for T-series.
I just wrote converge. It asks what converges to.
Yeah, for which it's possible to be valued. It's not possible. T-series don't have a formula, so you just stop it. Okay?
Mr. Clark, I'm good to take the test tomorrow, right?
Yes, in class.
Okay, sounds good.
All
All
right,
right, thank you.
Thank you.
I
Yes,
have
it
a
is.
lot of built-up anger.
Micaiah is an angry girl.